Welcome to the deep dive. Today, we are not talking about the usual AI hype cycle. We're not talking about chatbots or, summarizing your emails. We are talking about the industry's new line in the sand, a benchmark that I think separates the real AI experiments from, well, autonomous enterprise reality.
That's a good way to put it.
We're diving deep into the Agentblazer Legend status. And for anyone who's actually looking at the platform landscape, this is not just another certificate you stick on your LinkedIn profile.
No, not at all.
This is the pinnacle designation for a new role, really, the Agentic Systems Architect, and
Right.
we are focused exclusively on this top tier today.
And we have to be.
Why?
Well, because this level validates the kind of expertise you need to manage, frankly, exponential systemic risk.
Right. We are talking about autonomous systems that are now executing high-value financial transactions.
Manipulating global supply chains.
Processing protected health information, even? I mean, if you get this architecture
The
wrong,
consequences are measured in millions.
if not billions.
Exactly.
Yeah.
This is the architectural shift from what we used to call systems of record, the classic CRM infrastructure, where the human is the input device.
And the ultimate
A
executor.
human is the one who clicks send or approve.
Hmm.
And now we're moving to systems of agency, where the AI assumes that executive role entirely.
So if you're an enterprise architect or CIO, or really anyone responsible for compliance and governance,
We have to be listening.
then the legend status is the formalized, objective benchmark for the person who needs to design and maintain your cognitive infrastructure.
Yeah.
That mindset shift is crucial, and honestly, it's proving difficult for a lot of organizations to really grasp.
It is.
The second wave of Gen AI, your assistive co-pilot models, where the human is still the main router, the decision maker, that's rapidly becoming obsolete.
It's table stakes now. We
Yeah.
are firmly in the third wave of autonomous agents.
And the change in liability is really the architectural pivot point, isn't it?
It's everything. Look,
Yeah.
in the Copilot world, if the AI drafts a bad email, what happens?
The human user corrects it before they hit send.
Right. The burden of correctness stays with the human. But in this agentic third wave, if an agent autonomously executes a bad refund
Or misroutes inventory.
or mistakenly applies a regulatory decision, the damage is instant. It's often irreversible.
And that burden of correctness
It transfers entirely.
to the system architect.
The one who designed the guardrails, the audit trace, and crucially, the economic optimization strategy. This isn't about better prompt engineering anymore.
No?
It's about mastering system reliability engineering, but applied to probabilistic code.
And that's what the legend status validates. It recognizes that, well, that executive level responsibility required for handling these probabilistic, goal-oriented architectures.
Specifically those powered by the Agentforce platform.
Right. So we need to unpack how this architecture actually works, why traditional development processes fail here, and how every single decision connects back to the bottom line.
The new currency of the platform.
The flex credit economy. Let's start with the engine room.
Let's do it.
Okay, let's get into the core tech, because I think the default assumption out there is that any agent is just a standard large language model wrapped in a shiny UI.
That's the common misconception, yeah.
So what is the architectural difference here? We have to talk about the Atlas reasoning engine. What makes it fundamentally distinct from the LLM that's powering your typical conversational AI?
It's the pivot from intuition to deliberation. I mean, most public-facing LLMs, they excel at what we call System 1 thinking.
Fast, intuitive pattern matching.
Exactly. It's great for generating content, holding a simple conversation. It's quick, but it can be really prone to hallucination because it doesn't really pause to plan.
It just responds.
It just responds.
Yeah.
Atlas, which sits inside the Agentforce ecosystem, is purpose-built for enterprise action. And because of that, it relies on enforced System 2 thinking.
Slower, multi-step, rigorous.
A rigorous process.
Yeah.
It involves internal planning, it involves execution attempts, evaluation, and then refinement. It's designed to navigate the ambiguity of real-world business processes in a systematic way.
Okay, that sounds great in theory, but, how do you architecturally enforce a system to be slower and more deliberate in an environment where speed and latency are absolutely critical?
That's the tension you have to manage.
So if we peel back the layers, how does a legend architect actually view this cognitive cycle, this reasoning loop that's designed to maximize goal completion? Because it all has to start with perception, right?
Perception is the sensory layer, and it's so critical because it proves the agent is reactive, not just responsive.
What's the difference?
Well, it's not just getting a user query like, what's the status of my order? It's about receiving an event trigger. Think of a Kafka stream or a database transaction that sends a shipment delayed signal from a data cloud endpoint.
So something happened out in the world.
Something happened, and the agent perceives this external shift, and now it has to initiate its own proactive plan. It wasn't asked to do anything.
So the agent gets the signal, and then it immediately hits step 2, topic classification. Why is this so often the first major architectural failure point for architects who haven't reached this legend-level perspective?
Because classification is the routing mechanism, and bad routing is incredibly costly.
In latency and in credits.
Both. The architectural anti-pattern we see constantly, the one that guarantees inefficiency, is defining overlapping semantic topics. For instance, an architect defines a topic, get account balance, and also a topic, check available credit limit.
Okay.
Semantically, those are almost identical.
Yeah.
This overlap confuses the hyperclassifier, and that leads to low confidence routing.
And when confidence is low?
The Atlas engine is forced into longer, more expensive refinement loops just to figure out the user's intent. Or even worse, it has to ask clarifying questions, which completely defeats the purpose of autonomy in the first place.
Okay, hold on. Let me push back on that for a second.
Go for it.
Isn't that just semantics? Why would a super sophisticated large language model, a model this powerful, actually care if two topics overlap a little bit? Shouldn't it just be smart enough to figure it out? To disambiguate on its own?
It can figure it out. That's the trap. It's not a question of can it, it's a question of should it.
And at what cost?
And at what cost? Every computational cycle it spends disambiguating your sloppy topic design is a cycle that costs you flex credits and adds latency. A legend architect understands their primary job is to create the cleanest, fastest path.
So they enforce distinct, non-overlapping boundaries.
For every single topic. To ensure high confidence routing immediately. Look, if you have two topics that are 80% similar, you architecturally merge them.
You don't leave it to chance.
You merge them, and then you use internal logic, like agent script, which we can get into later, to handle the 20% divergence. You don't burn expensive LLM steps on classifying ambiguous intent.
So it's about economic viability, not semantic purity.
That's it, exactly.
That makes sense. It's about minimizing that probabilistic overhead. Okay, so once the topic is classified with high confidence, we move to context assembly. This is where the agent decides what information it actually needs.
Yes, and this is where the legend architect has to be extremely judicious. It's not about just grabbing the last 6 turns of a conversation history.
It's about bounding the context.
Bounding it, yes. They retrieve metadata, and critically, they inject specific instructions that are associated with that unique topic. And maybe most importantly, they only inject the necessary tools.
The available actions.
The available actions APIs, flows, MuleSoft endpoints, they only inject the ones relevant to that topic into the context window.
Why the tight constraint on tools, though? Why can't the agent just pick from a big list of all available APIs in the company?
No, absolutely not. The constraint is vital for 2 reasons: security and efficiency.
Okay, let's start with security.
Security, because if you inject the delete all customer records action into the context of an agent that's only supposed to update billing address, you are inviting a prompt injection attack to try and call that forbidden action.
You're opening a door that should have been locked.
And efficiency, because a larger context window filled with irrelevant actions requires more tokens for the LLM to process and evaluate. That increases latency and it increases cost. The legend architect uses context assembly to prevent the agent from wandering off topic or, worse, executing unauthorized actions.
So now we are at the core of the System 2 process: plan formulation and action execution. Tell me about plan formulation, this internal monologue. Is the agent literally writing out a plan before it acts?
It is. And this is the visible trace of that System 2 thinking. The Atlas engine generates a step-by-step internal monologue. It assesses everything.
Like what?
Okay, given the initial query, the context I just assembled, the specific instructions for this topic, and the 3 available MuleSoft actions, what's the optimal sequence of steps to get to the goal?
And what's the specific API I should call right now?
Precisely. It's rigorous, it's self-questioning. It might hypothesize, okay, step 1, I need to check the inventory level, but wait, first, I must retrieve the user's preferred warehouse ID. It's planning its moves.
And if that plan hits a wall during action execution, let's say an API call fails or the data it gets back is insufficient, that's where the refinement loop kicks in.
Correct. It doesn't just throw its hands up and fail. It cycles back to the plan formulation step. It evaluates the failure or the insufficient information. It refines its internal monologue.
It learns from the mistake.
It learns in real time. It might diagnose, okay, the initial plan failed because the API returned an HTTP 403 error. My new plan is to attempt an alternative API call, action B, which has a fallback mechanism. And then it tries again. This iterative process is what makes a probabilistic system resilient enough for the enterprise.
Okay, this brings us right back to the money. This concept of cognitive optimization is where architectural mastery directly impacts the economic bottom line. If every LLM call, every cycle through that loop costs money, how does the Legend architect make the system fiscally responsible?
It is, and I'm not exaggerating, it is the fiduciary duty of the architect. If an unoptimized agent takes 5 reasoning steps to resolve a query, that's 5 LLM calls, 5 credit burns, 5 latency hits.
For one interaction.
For one single interaction. If the Legend architect refactors the instructions and optimizes the action descriptions to guide the Atlas engine more efficiently, they can solve the identical problem in 2 steps instead of 5.
That's a 60% reduction in cost and latency.
Compounded over millions of transactions, it's a massive financial impact.
Can you give me a simple, concrete example of optimizing an instruction?
Absolutely. A general, poorly written instruction might say, if the user mentions an order, search for it.
Okay, that sounds reasonable.
But it leaves the agent to figure out how to search. An optimized instruction would be much more specific. It would say, if the user provides an 8-digit order ID, you must execute action get order by E first, using the variable order ID exactly as provided in the user's input.
So you've replaced a probabilistic search strategy with a deterministic action path.
Exactly. You just save 2 or 3 reasoning steps. This is how you move autonomous agents from a fascinating experiment to a scalable, profitable enterprise solution.
But we still haven't resolved that fundamental tension. System 2 thinking, by design, is slower than System 1. If this agent is fielding real-time customer service requests, we have a hard latency budget, maybe 1.5 seconds maximum for a resolution.
It's a tight window.
How does the architecture afford the time for that deliberative planning?
That's the critical technical constraint, and the answer lies in the hyperclassifier. We cannot afford to wait for a complex, heavy encoder-based model to classify intent at the start of every single transaction.
It would eat the entire budget.
It would. The hyperclassifier is a highly specialized architecture, usually a much smaller, faster model, designed for one job and one job only. Produce a decision, the topic routing in a single, predictable output token.
A single token that has to be almost instantaneous. You're effectively abstracting away the initial classification time.
Precisely. That instantaneous decision allows the agent to route the request immediately, preserving the vast majority of the latency budget, say 90% of the allowed time, for the complex, expensive work that must happen next.
The actual System 2 reasoning, the data retrieval, the action execution.
Right. The Legend understands that the job isn't making the LLM faster. It's about making the non-LLM steps faster. And ensuring your topic definitions are concise and distinct is the key to achieving that peak hyperclassifier efficiency.
So autonomy is completely useless if it's just hallucinating.
Right.
The smartest agent in the world with the most rigorous System 2 logic is still fundamentally dependent on the truthfulness of the data it's grounded in. Which brings us to the mandatory foundation of any agentic enterprise, data cloud.
Data cloud is absolutely the mandatory starting point. An enterprise agent can't operate solely on the general knowledge embedded in its base LLM. It has to be grounded in real-time, proprietary, trusted data.
And RAG retrieval augmented generation is the mechanism for that.
RAG is the mechanism, and the vector database inside Data Cloud is the core technology that you use to index all that unstructured data. Your internal compliance manuals, PDF contracts, customer service chat logs, knowledge base articles, all of it gets vectorized.
The Legend architect's responsibility here moves way beyond just, connecting the dots. It's about configuration mastery. They're configuring the search index. They're making these crucial decisions about chunk size and overlap. Why are those configuration decisions potential time bombs?
Because they determine the quality of the context that gets delivered to the Atlas engine. And therefore, they determine the agent's ability to act correctly. Let's talk about the 2 primary failure modes here.
Okay.
If your chunk size, the amount of text you retrieve for a single piece of context, is too small, the agent suffers from what we call context starvation.
It's not getting enough information.
It's getting isolated fragments.
Right.
For example, it might retrieve only the definition of a company policy, but not the critical sentence that explains the condition under which that policy applies. The agent can't form a coherent, context-rich answer. So it will either hallucinate to fill in the gap or gets forced into another expensive refinement loop.
And the opposite problem, if the chunk size is too large.
That leads to context poisoning. Now you're retrieving massive, irrelevant blocks of text. This overwhelming, sometimes contradictory information just distracts the model.
It's noise.
It's noise. The agent starts prioritizing irrelevant details, and that leads to hallucinations or incorrect actions based on information that should have been excluded in the first place. A legend architect doesn't use a universal setting for this.
It has to be tailored.
It has to be calibrated. These parameters, chunk size and overlap, are set based on the source material, a legal contract. That requires small, highly specific chunks to preserve the integrity of each clause. But a long descriptive Slack thread might require larger chunks with more overlap just to capture the narrative flow of the conversation.
Now let's talk about what I think is the true enterprise game changer mandated by this level of architecture. Zero copy. I mean, we have spent decades building complex, costly ETL pipelines just to move data around. Why does zero copy integration completely dismantle that traditional, expensive approach for autonomous agents?
Because traditional ETL extract, transform load, creates three unforgivable sins in the age of agency: latency, duplication risk, and governance headaches.
Right. Every time you copy regulated data, PHI, PII, financial transaction details into a new environment,
You inherit the full compliance burden for that copy. You've just doubled your attack surface. Zero copy integration is a mandate for legend-level architects because the data is virtualized, not moved.
Can you break down the actual mechanism there? How does the Agentforce platform perceive external data as if it were native without physically hosting it?
The architect maps external data tables, which are sitting securely and physically in Snowflake, Databricks, or transactional core, to what are called data lake objects, DLOs. And then they model those into data model objects, DMOs, within the Customer 360 data model.
It's a virtualization layer.
It is. The agent sees a DMO called external telemetry log, and it reasons over it just as if it were a native Salesforce object. But the data physically remains in its original repository. Salesforce only holds the metadata and the pointer.
So the strategic advantage isn't just saving on storage costs. It's fundamentally about risk and speed.
Precisely. It allows for real-time reasoning over petabytes of high-volume external data telemetry, high-frequency trading logs, manufacturing sensor data, without the prohibitive time and risk of moving at all. This is the only scalable way to achieve strict data residency requirements, especially with things like GDPR.
So a US-based Agentforce instance can reason over European customer data.
Securely, without violating any sovereignty rules, because the data never physically left the EU region. If you are operating a global enterprise, this is the architecture you must mandate. There is no other way.
Okay, so an agent with trusted, real-time data is intelligent, but it's still passive. It's an advisor until it can actually act. Enterprise action requires hands, and in the current platform stack, those hands are MuleSoft orchestration.
MuleSoft is that critical integration layer. It exposes your legacy systems, your SAP, your mainframes, your old Oracle databases, to the probabilistic AI brain. It's what turns opaque, complex, multi-step backend processes into consumable, declarative agent actions.
But integrating an API for a human user is one thing. Integrating an API for an autonomous agent is completely different. The Legend architect has to enforce specific API governance for agents. What's the difference? I mean, what makes an API truly agent-ready?
You have to design for maximum resilience and security against the very nature of probabilistic systems. The first non-negotiable is idempotency.
Meaning you can call it multiple times with the same result.
Exactly. An agent, due to its probabilistic and networked nature, is designed to retry failed API calls, especially during that refinement loop we talked about. If you expose a non-idempotent action, say a simple create order endpoint, and the network has a momentary glitch,
The agent might retry.
it will retry, and now you have two identical orders being created in your backend system.
And the high-stakes consequence there isn't just a simple mistake.
No, the consequence is chaos. Imagine a wealth management agent processing a portfolio rebalance. If the execute sell order API is not idempotent and the agent retries because of a micro outage, you could accidentally sell the same block of stock twice.
You don't just lose 10 cents in flex credits.
You execute a $500,000 transaction error that becomes an immediate board-level crisis. The API must ensure that executing the same action multiple times yields the identical singular result.
And the second critical factor, which links back to security.
Context injection. The Legend architect has to ensure the agent operates strictly within the security boundaries of the human user who invoked it, or the system user it's impersonating. MuleSoft gets configured to inject additional context, like the user's specific entitlements, directly into the API call header.
So the agent can't go rogue.
It means the agent cannot access or modify highly confidential account data via the backend system if the associated human user wouldn't have the permissions to do so on the front end. This is mandatory action control, enforced at the integration layer, proving that the agent respects all your existing security policies.
This feels like the right place to pivot then, because the fundamental shift in security is moving from access control, who can see the data,
To action control, what the AI can actually execute across the entire enterprise ecosystem. For any senior leader, you have to acknowledge this. A rogue agent capable of complex, high-velocity actions across distributed systems is a far, far higher risk than a rogue human user.
A human can only input data at typing speed. An agent can process millions of API calls in seconds. So the governance can't be an afterthought. It has to be the foundational layer. This is why the Einstein Trust Layer is so critical. It acts as the secure gateway, mediating every single interaction with the underlying LLMs.
It is the secure proxy. It
Sure.
sits between your proprietary data and the external model. The Legend architect's mastery here is judged by their rigorous configuration of data masking. We have two core methods, and understanding when to use each is the difference between passing and failing a compliance audit.
Pattern-based and field-based.
Exactly.
Let's elaborate on that distinction. You mentioned pattern-based masking uses regular expressions.
Yes, pattern-based is for your standard, globally recognized sensitive data. We use regex to detect the predictable patterns of social security numbers, credit card numbers, email addresses, or specific international identifiers. The trust layer detects that pattern, and before it sends the prompt to the external LLM, it replaces the actual data with a placeholder token.
Something like CCN number 1 or SSN2. And field-based masking. This sounds more specialized.
It is. It's for your high security, proprietary, or custom data that's unique to your organization. This is huge in highly regulated sectors like pharmaceuticals or defense. The architect designates specific, named CRM fields, high security contract terms, or executive compensation package for automatic masking, regardless of whether they match a standard pattern.
Why use both? Why not just mask everything to be safe?
Because the LLM needs just enough context to perform the logic without ever seeing the sensitive values. Pattern masking handles your general compliance, like PCI or PII. Field masking handles your unique, proprietary regulatory requirements. The critical result of both of these processes is zero data retention by the LLM vendor.
So the external model processes the logic.
It processes the logic. Does the account holder with SSN1 have a high enough credit score to qualify for this loan, without ever seeing the actual social security number? Then, when the LLM returns the generated logic, the trust layer swaps the real data back into the placeholders before displaying the output to the agent or the human user.
That truly is the architectural solution that mitigates the biggest compliance fear in generative AI, that fear of leaking PII to a third-party model. But let's address another major risk: toxicity and jailbreak mitigation. Agents are massive targets for prompt injection attacks.
They are. Malicious users are constantly trying to trick them into overriding operational instructions or security policies.
So what's the control?
The Legend architect's crucial risk management decision here is configuring the toxicity confidence score thresholds. This threshold determines when the agent will immediately terminate the session and flag the interaction as dangerous or malicious. And this decision is highly contextual. You have to establish a distinct policy for different agent personas.
Give me a contrast.
Okay, a public-facing customer service agent interacting with the general public. It must have a very low threshold and a very high sensitivity. Any hint of toxic language or a clear jailbreak attempt has to result in immediate termination. You can't risk a negative PR incident or a policy breach.
And on the other hand,
An internal developer agent, one that handles technical discussions involving code snippets, error messages, maybe even internal security testing. That agent might require a slightly higher threshold
to avoid false positives.
to allow for robust technical conversations that could accidentally trigger the toxicity filter. This is a risk versus utility balance that the Legend architect has to own and defend.
But security is meaningless if you can't prove it worked. In regulated sectors, finance, health, insurance, the legal question is never what happened, but definitively why the AI made a particular decision. This requires a dedicated forensic audit architecture.
You have to design this forensic trace from end to end. We need two logs captured and indelibly linked together. First, you need the reasoning trace.
The agent's internal monologue.
It's the agent's internal monologue, the sequence of decisions, the plan it chose, the alternative plans it discarded, the specific RG documents it retrieved, and the confidence scores for its topic classification. All of these logs must be captured and stored in Data Cloud for long-term retention and regulatory review.
And the second log is connecting that thought process to the actual system change.
Yes, you have to link the field audit trail, the definitive record of the database change itself, back to the specific agent execution ID from the original conversational context. If an agent recommends and executes a loan denial, you need to be able to prove, under regulatory scrutiny, that the decision was based on non-discriminatory data and followed the mandated policy flow.
So this linked trace proves non-discrimination, ensures 100% auditability.
And it ties the probabilistic action back to the definitive deterministic database outcome. It's a legal necessity.
You cannot govern what you cannot see, which naturally brings us to observability and the control plane. The Agentforce Command Center is helpful, but true Legend architecture extends visibility across the entire technology stack.
And that requires open standards. The Legend leverages OpenTelemetry, OTel, which is the industry standard for exporting agent telemetry traces, metrics, logs out of the Salesforce platform and into your enterprise monitoring stacks like Splunk or Datadog. You have to be able to view the agent as just one component in a much larger, sprawling system.
Give us a concrete, high-stakes example of why OTel and distributed tracing are indispensable for operational reliability.
Okay, imagine a customer initiates a complex claims process via a mobile app. The request flows from the mobile app to the Salesforce agent for reasoning, to MuleSoft for orchestration, and then to a legacy backend Oracle database. The entire process times out after 15 seconds.
And without distributed tracing, you're flying blind.
You're blind. With OTel, the trace reveals the precise bottleneck. It might show that the agent's reasoning loop took 2 seconds, MuleSoft took 1 second, but the query to the 30-year-old Oracle database took 12 seconds to return.
That's crucial. You stop optimizing the wrong thing.
Exactly. You realize the bottleneck isn't cognitive optimization. It's database tuning or network latency. Without OTel tracing, the architect would waste weeks refactoring the agent's instructions when the real problem is IT infrastructure. It reveals if the latency is the agent's fault or the system's fault.
And finally, a huge governance risk for modern enterprises: shadow AI discovery. Employees, eager to innovate, will inevitably build quick agents or proofs of concept outside of official IT channels.
This is a massive compliance exposure. The Legend architect must implement continuous governance monitoring. They deploy specific tools, often third-party tools integrated via APIs, to auto-discover active agents that were built without IT oversight.
And these tools flag what exactly?
They immediately flag any agents accessing sensitive data, attempting zero-copy reads across data sovereignty boundaries, or making unauthorized API calls. You have to actively hunt the shadow AI before it creates a massive, unauditable compliance breach, essentially turning a helpful employee experiment into a major legal liability.
We've established that the agent development lifecycle, or ADLC, for probabilistic systems requires a rigorous engineering discipline that traditional CRM development simply didn't. This is not the standard agile deploy and forget methodology.
No way.
It starts with a Legend-level skill: ontology strategy.
Ontology is the structured definition of your business domain for the AI. If you get the conceptual mapping of your business processes wrong at this stage, everything downstream, classification, reasoning, execution, will be inefficient and costly.
And the most common architectural anti-pattern here is the monolithic topic, trying to define one massive topic like manage account or handle customer inquiry.
It's a guaranteed path to failure because it creates massive ambiguity for the hyperclassifier, and it forces the Atlas engine to load unnecessary complexity into its context window, which just drives up your Flex credit consumption. The Legend architect enforces the decomposition strategy. They break that monolithic topic into granular, distinct, and semantically unique topics.
Like update billing address, review recent orders.
File an escalation request. Exactly.
I understand the efficiency argument, but what's the mandatory element there?
Granularity is mandatory because it maximizes hyperclassifier accuracy. It knows precisely where to route the request, and it severely constrains the scope of the reasoning engine. By constraining the scope, you ensure the agent isn't trying to remember the entire enterprise manual just to change an email address. This is the first crucial step in cognitive optimization and cost control.
Now, Agentforce provides low-code tools like Prompt Builder, which is fantastic for creating reusable templates. But when you are dealing with high-stakes financial transactions, that natural language probability is often an unacceptable risk. You need
Yeah.
pro-code guardrails to guarantee absolute determinism.
Absolutely. Natural language, by its very definition, is probabilistic, it's fluid, it's ambiguous. You cannot guarantee with a simple prompt that an LLM will execute a loop exactly 10 times, or use a complex nested conditional logic structure exactly as required by a compliance mandate.
So for those mission-critical sequences,
The Legend architect utilizes agent script.
that's the domain-specific language, the DSL. How does that interact with the probabilistic Atlas engine?
Agent script lets the developer define precise control structures, loops, complex error handling, conditional branching, that natural language cannot reliably guarantee. It injects a layer of deterministic logic directly into the probabilistic agent flow.
Can you give an example?
Sure. If a financial transaction requires 3 external checks to run in order, let's say credit check, then fraud score, then a sanctions list check agent script ensures that those 3 steps execute exactly the same way, in that order, every single time, regardless of how the Atlas engine might be feeling that day.
That leads us to the monumental challenge of testing probabilistic systems. If the output varies slightly on every single run, traditional pass-fail Boolean testing is obsolete. How do you test a system that's designed not to be 100% predictable?
You have to transition from binary testing to quantitative statistical validation. Legends rely on the Agentforce testing center with large golden datasets, hundreds or thousands of verified input-output pairs. Testing then focuses on statistical metrics.
So you're looking at things like resolution rate.
Resolution rate, exactly. The percentage of queries solved autonomously without a human handoff. We track hallucination rate, the frequency of factual errors based on the RGRAG data, and most importantly, action accuracy.
Ensuring that when the agent executed a flow or a MuleSoft call, it executed the correct API with the correct parameters.
Every time.
And what about the inherent risk of introducing new complexity? You add a new agent, a new topic.
That's the danger of topic drift, or, as it's sometimes called, catastrophic forgetting. When you deploy a new agent, say, an HR benefits agent, that new semantic space might inadvertently degrade the performance of an older, stable agent, like the order status agent.
Because the hyperclassifier finds new, confusing semantic overlaps.
Precisely. Legends run full regression sweeps before every single deployment. They validate all existing successful golden datasets to catch these subtle drifts, ensuring they don't solve one problem while creating 2 new, hidden operational stability issues.
Now, let's bring this back to the boardroom. This architectural discipline is a fiduciary responsibility because we are all operating in the flex credit economy. This is the consumption-based pricing model.
This is where the rubber meets the road. Agentforce is priced on flex credits, roughly $500 per 100,000 credits. Every step, every LLM call, every flow execution consumes credits. It's around 20 credits per action, which translates to approximately $0.10.
10 cents seems trivial, but that's the definition of a scaling risk. If you're handling millions of transactions and your poorly designed agent enters a 10-step reasoning loop instead of a 2-step loop,
You are adding $0.80 per transaction in unnecessary cost.
that adds up to a massive P&L exposure.
Precisely. This is why the Legend strategy for optimization is mandatory. You must design efficient paths to guide the agent in the absolute fewest steps possible. The key performance indicator for the Legend architect is the credits per resolution metric, the average cost to solve one problem.
And if that number starts to climb,
The Legend refactors the instructions, implements caching strategies for static data to avoid redundant LLM calls, and optimizes the RAG index to reduce unnecessary retrievals. The Legend makes the architecture economically viable.
but the ultimate metric isn't credits saved. The ultimate metric has to be ROI modeling, outcome value. We have to move past the champion view, which is, hey, the bot saved 5 minutes of human time.
The Legend view is strategic, and it's outcome-focused. It's about quantifying business outcomes in financial and compliance terms. It's, the bot reduced our cost to serve by 18%. Or, far more powerfully, the bot ensured 100% compliance on transaction dispute disclosures, which reduced our potential regulatory fine exposure by X million dollars.
Let's use the concrete examples we sourced to illustrate that outcome value. Start with financial services. Transaction dispute management.
This is high-risk, high-compliance work. A Legend architect automates the entire multi-step process. Identity verification, transaction selection, reason code entry, and most critically, applying provisional credit based on automated risk scoring.
And they implement mandatory human handoff triggers.
For specific high-risk thresholds, For instance, any dispute amount over $500 requires agent intervention. The outcome value is threefold. Instant provisional credit for low-risk customers, which dramatically boosts customer satisfaction. 90% automation of tedious, high-volume work and complete irrefutable auditability of the entire process via the trust layer logs, which virtually eliminates the risk of compliance fines.
And in healthcare, patient access orchestration, the architectural stakes involving PHI are arguably even higher.
It's a perfect demonstration of zero-copy and orchestrated agency. The agent has to reason across the EMR, the electronic medical records, via Health Cloud. It has to check provider availability and verify insurance eligibility via external payers.
And the Legend architect uses Data Cloud and zero copy.
So the agent can reason over the EMR data streams, which contain PHI, without ever moving that data out of the secure EMR boundary. That ensures HIPAA compliance. The resulting value is dramatically reduced no-show rates due to proactive, autonomous rescheduling and 24/7 symptom triage. It improves patient flow and increases hospital revenue, all while adhering to the most stringent data regulations in the world.
So we've established that this level of architectural mastery is required to manage systemic risk. And the validation for this is not trivial. The Agentblazer Legend status requires passing the Salesforce Certified AI Specialist exam, often referred to as the Agentforce Specialist. This high-stakes barrier filters out the dabblers.
It is a proctored, high-stakes test. 60 multiple-choice questions over 105 minutes, and it requires a 73% passing score. It's explicitly designed to distinguish those who understand generic AI concepts from those who have mastered the Agentforce architecture and its critical governance layers.
Let's reinforce the domain weights to show where the expertise must lie. This is not a test of prompt memorization.
Not at all. Prompt engineering is a mere 20–30% of the exam, and it focuses on grounding techniques and the proper use of Prompt Builder. The bulk of the exam, around 30%, is on Agentforce concepts itself.
So detailing the Atlas reasoning engine.
The reasoning engine, the proper methods for topic management and decomposition, and the testing framework. The rest of the weight is on data cloud integration, advanced flow builder for headless flows, and crucially, trust and security.
Meaning deep, practical configuration of the trust layer and masking policies.
Exactly. And beyond the multiple choice, this validates hands-on technical skills, using the SFCLI for deployment, debugging the reasoning trace, and most importantly, writing agent script, that DSL, to ensure you have deterministic guardrails around your high-stakes actions.
Furthermore, the Legend role is not solely technical proficiency, it demands organizational leadership.
Yes, they chair the AI Center of Excellence, COE. This centralized body is responsible for establishing the governance standards, for vetting and approving all new agent use cases across the enterprise, and for defining the organization's risk appetite for autonomous execution.
They are the organizational guardians, the ethical stewards, responsible for compliance and responsible deployment.
And that responsibility means constantly reviewing the audit logs and reasoning traces to mitigate unintended bias, and crucially, implementing mandatory human-in-the-loop protocols for high-stakes decisions.
Like large loan approvals?
Large loan approvals, critical medical referrals, or financial dispute rulings. This is executive governance baked directly into the system design, ensuring that the final, most consequential steps are always subject to human review.
So if I'm an enterprise architect listening to this who must care about the Legend status right now, and who can perhaps treat it as aspirational for the next few quarters.
Anyone responsible for compliance, governance, organizational risk management, or digital transformation strategy. So, enterprise architects, solution architects, CIOs, you must care. If your organization is planning to use autonomous agents to execute transactions with material financial, health, or legal consequences, achieving the Legend level in your staff is a requirement.
It's your professional insurance policy.
It is. It's your insurance policy against systemic failure and regulatory fines.
And who can afford to wait?
Anyone still focused solely on email summarization, internal knowledge search, or basic assistive co-pilot functionality. If your AI system is only assisting human activity and not actively executing tasks that carry inherent financial or legal consequences, then the Legend level remains aspirational.
For now.
For now. But look at the market trajectory. The enterprise is moving unambiguously toward full agency. You will not be in the aspiration phase for long.
The Legend architect of today is not just solving current business problems. They're building the security and governance frameworks for the immediate future. And that future is the agent-to-agent economy. The A2A economy.
That's the strategic endgame. We are moving beyond human-to-agent interaction. Through open protocols like the Model Context Protocol, or MCP, Agents built on Agentforce will soon be able to directly call, negotiate, and transact with agents built on other platforms.
Whether that's a competitive CRM system or a legacy ERP platform.
Doesn't matter.
This means that by 2026, agents won't just execute pre-planned tasks, they will negotiate terms. Think of your procurement agent autonomously negotiating pricing, delivery schedules, and compliance terms with a supplier agent located on a completely different platform's architecture.
And the critical security, idempotency, and auditability frameworks that the Legend architect designs today.
Are the enabling architecture for this vast machine-to-machine economy?
Which brings us to our final, provocative thought. The architectural validation, represented by the Agentblazer Legend status, proves that enterprise AI platform development is no longer optional customization. It is disciplined, probabilistic engineering.
Right.
If your architecture isn't optimized to track and minimize the cost of 10 cents per reasoning step, and if it doesn't guarantee 100% auditability for compliance, then your autonomous workforce is not a strategic asset. It is a massive, unchecked financial and legal liability just waiting for the first major compliance breach to expose it.
If you found this deep dive into architectural risk and economic optimization necessary for your role, you need to stay ahead of the hype cycle. Subscribe to the deep dive. We break down complex platform shifts without the marketing fluff, giving you the real state-of-the-art and the actionable insights you need to lead your digital transformation efforts. Don't wait for the market to catch up. Be the leader who defines the next era.